Hi, this is Miss Reese. I'm going over the exponential functions practice test for Unit 9. I'm going to do the left column with you, or all of the odd problems. So first we want to know if this sequence is geometric. So you are going to need to take your first term, or really any term. Let's multiply, see what we need to multiply it by to get to the next term. So in order to solve for b, we can divide and we get b is -3. That's our common ratio. And what you could do is just verify that that works for the entire pattern. So -2 multiplied, I'm sorry, this would be +3. Our common ratio is +3. So -2 multiplied with 3 is -6. -6 multiplied with 3 is -18, and -18 multiplied with 3 is -54. So this common ratio of 3 works throughout the entire pattern. So then, yes, we know this is a consistent geometric sequence. For a common ratio, so we don't need to necessarily check from one term to the next. We would just set up our equation like this as well. So 4 multiplied with what number is -16? And then we could just divide by 4. And that gives us a common ratio b, or I guess we could use r in this case, as that would be -4. Okay, so we're multiplying by -4 each time here. Given the sequence, we're writing an explicit rule. A rule you might want to look back at your toolkit. This would be just the top portion of your toolkit. It is Unit 9. So we need two things when we're writing out the rule. We need our 0th term, so the term that comes before the one that's first, and then we need our common ratio. So we have -1 multiplied with b. Our common ratio is 4. So then let's divide by -1. So we have a common ratio of -4. And what we also need is our 0th term. So I can go ahead and eliminate these two choices, so I know it's between one of these two here. So what we're going to do, we have our first term. So first term is -1. We want to, instead of multiplying by -4 to get to the next term, we're going to do the opposite of multiplying. So we're going to be dividing. So -1 divided by this common ratio is equal to, and that would simplify to 1/4, 1/4. So this is going to be our equation here. So if you were to imagine that there was a number that came before this number here, it would be 1/4, comma. And then if I multiply 1/4 with -4, I'm going to get -1. Multiply -1 with -4, I'm going to get +4, and so forth. Okay, great. Question number 7, we're going to do the same thing that we just did here, but we are then going to find what our 10th term in that sequence would be. So first step, 3 multiplied with what is equal to -12. Can divide by 3 on both sides. So that gives us a common ratio here of -4. And then I just need to figure out what my 0th term is. So it looks like we're multiplying by -4, multiply by -4, multiply. Okay, so our opposite of that, we're going to have to divide by -4. So 3 divided by -4, well, that's just -3/4. Or you can do a decimal, 0.75. Doesn't matter. So that would be our 0th term. So I'll call that a sub 0. I'll just do an arrow to that. Great. And so for writing out our equation would be a sub n equals our 0th term multiplied by our common ratio to the power of n. But the number that we're going to use for this is 10. This is our 10th term. So I'm going to do 10 here, 10 here. And then I would just put this into your calculator. And again, you could put this in your calculator as a 0.75, -0.75. I'll go ahead and do a fraction since I have the ability on this calculator. And then we have to the power of 10. So we would get a sub 10 equals, and here we go. So make sure you are writing down some type of equation and what your ratio is for this problem. The other way to have figured this out, we're in term number 1, 2, 3, 4. Technically, you could have then verified this by multiplying by -4 and keep going until you get to the 10th term. That also works. Okay, on our second page here, Oops. Oh, yep, we're starting with some graphs here. So remember the equation for our graph is y equals a, and then we have parentheses b, common ratio to the power of x plus k. And so for these equations, remember we are creating like essentially a table of values. So if we look kind of at our toolkit here, we had some things that we were looking at in terms of, is it growth or decay? What's our domain? What's our range? What are some of our x or y, or what's your y-intercept and what's the asymptote? So for this, I think what would be helpful to use is we can first identify for this one, our a value is 4, our b is 1/2, and then there is nothing being added or subtracted after, so we could just say k is 0, okay? Now we do know that since this is 1/2, this is a decay. So I do know that the equations that show decay are going to be A and B. So for C and D, I'm just going to cross those out. And then the other thing I might want to do is just create a little table of values and plug in a few things just to make sure my graph matches up. So usually I just plug in a few things. Looks like we're at a -2 here. I'm going to plug in a -2 to see what I get out. I'm going to plug in a 0 and a 2, +2. Since this graph is going by 2s, I'm going to plug in 2s. You could do -1 and -2 also, but I'm just going to use these values that we have here. So 4, and then we're going to do to the power, our common ratios with 1/2. And then let's raise that to the power of -2. That's going to give us 16. I'm just going to do the same exact equation. We're going to delete that, and we're going to do a 0, power of 0. Remember, anything to the power of 0 is 1. So this is really 4 times 1, 4. Oh, this is our y-intercept. Great. 0, 4. Okay, that's here. And let's just check. Let's just make sure. Let's plug in a 2. Oh, there we go. Enter. And I'm going to change this 0 to be a +2 power. Here we go. And that's a 1. So the graph that matches with that is going to actually be this one here. So at -2, I have a point at 16. Looks good. 0, I have a point at 4. And then at 2, I have a point at 1. So this looks accurate. This is close, but not quite. It looks like our y-intercept is more at 5. And it's a little bit steeper in the graph here. So B does not work for that equation. So I would recommend for this next one, you can identify your A, B, and C, or A, B, and K. And then I would also just maybe make a table, and you could do the same values that we did here. That should work for you. On next page, our A is 2, our B is 2. That means this is a growth equation, it's increasing. And our K is -1. Let's plug in a few values. I'm going to do -2, 0, and +2 again. Okay, so we've got 2 times 2 to the power of, where's my power button? -2 minus 1. That's going to be -1/2. When I plug in 0, 2 times 2 to the power of 0. Remember, anything to the power of 0 is 1. That's really going to be 2 times 1. And then we're going to subtract 1 from that. So it's going to be at 1. And so if you think about it, it basically took our y-intercept of what a graph would be if it had nothing added here, and it kind of shifts it down a little bit. So it's down 1 unit from our, what we call kind of sometimes the initial value. And then when we plug in 2, let's see what we get here. 2 times 2 to the power of 2 minus 1. It's going to be 7. So let's look at the graphs that match with this. So we need a growth equation. So I can cross out B, I can cross out C. So we're looking at or choosing between graphs A and D. Well, I know my intercept is at 0, 1. That works for both of these. But I'm also looking for a point at about 2, 7. And so that'll match actually closer with this graph here, A. And if you notice, our asymptote is reaching -1 here, is what it looks like. So this will be graph A. All right, we're going to do 13 together. We've got an exponential growth formula because we're looking at an increase. We have a population, initial population of 422,000. And our rate, we're going to write this as a decimal. It's going to be 0.12. So 12% is 0.12 as a rate. So y equals, we do the initial value, 422,000, and then 1 plus that rate to the power of t. So this would be our actual equation. So I'm just kind of getting this from my toolkit here. So if that's our equation and we want to know after 8 years, I'm just going to plug in 8 into that equation. And I'm just going to put 1.12 because that's what I would get if I added those two together. And then that would be to the power of 8. So 1,044,856. And you notice we're not putting 0.46 because, this is people. So we're just going to put to the nearest person here. You're going to try 14 on your own, and we'll do 15. So this is depreciating, decreasing in value. This is an exponential decay problem. So let's write out our initial value of 13,000, and then our rate is 0.15. And then let's write our equation, 13,000. Now, when it's a decay problem, we subtract that and to the power of t, and we're going to say 5 years for this. So essentially, if we're losing 15% after a year, essentially is what that's telling you, it would be worth 85% of what it's originally worth. So we can say 13,000. You can put 1 minus 0.15, that's fine, or you can put 0.85, and then we're going to raise that to the power of 5 because we're doing 5 years. So that's going to be here. And since we're in money, we're rounding it to the nearest cent. 16, you're going to try on your own. And remember, 3%, that should be 0.03 as a decimal, right? Okay, let's do question 17. Which common ratio or b value would represent exponential growth? So let's look back at our toolkit, and we know that our value needs to be greater than 1. So if we're looking at all these values here, 0 is not bigger than 1. This is not bigger than 1. This is also, so it's going to be 6 here. Our common ratio should be 6 for this equation to make our exponential growth. Okay, you're going to try 18 on your own. Yeah, and then we're on our last page here, which represents exponential decay. So we need to be between 0 and 1. And if you're not sure, like what's 8 over 3? It's going to be 2.6. So that's not between 0 and 1. Neither are these two. This is between 0 and 1. So it's very close to 1, but not quite. For the exponential function, so remember, this is our a value, this is our b, this is our k, and remember our y equals k is the equation for our asymptote, the line that the graph approaches, so it'd be y equals 8 for that. So this is our k, a, and this is our b value. So just making sure that you write out your equation and maybe draw a line or point to it and put like y equals k is the equation for that. For the exponential function, what is our y-intercept? So remember, our y-intercept is when our x value is equal to 0. So we're going to plug a 0 in here. So y equals 3 times 4 to the power of 0 plus 8. Well, remember, anything to the power of 0 is 1. So this is going to be 3 times 1 plus 8. 3 times 1 is 3. And 3 plus 8 is going to be 11. So when I plug a 0 in here, my output is 11. And then our last equation here, the asymptote, the line that the graph approaches, the horizontal line that the graph approaches is right here. And this is at -5. And then remember, this is a y equals equation. Horizontal lines are always y equals graphs. So this would be a y equals -5.